Hi, I'm Craig Rowland, founder of Sandfly Security. In today's video, I'm going to demonstrate how to use Sandfly's agentless drift detection to monitor any Linux device for unauthorized changes. Sandfly's drift detection works on cloud-based, on-prem, even embedded devices to tell you whether or not anything in that system has changed away from a baseline norm that you expect. This means that we can not only find intruder activity on systems you don't expect to change, such as cloud-based images, but also for incident response, you can make a known good image and then use that to rapidly check systems to see whether or not they drifted from that baseline so you could concentrate your investigation resources where they matter most. So let's hop over to the user interface. I'll explain how all this works. I think you're going to find this to be an extremely powerful feature that you can use immediately with our agentless deployment. So let's get going. All right, we've logged into the user interface, and before we get into the demo, let me explain a little bit more in detail about what drift detection is from Sandfly's point of view. Drift detection is Sandfly's ability to basically profile a system and tell you whether or not any significant changes have happened to critical parts of that operating system. Now, a lot of you may be familiar with what's called file integrity monitoring, and this is where you could point it at a directory and say, tell me if any files have changed here. Sandfly does that, and that's all well and good. But the problem with a lot of modern Linux malware is a lot of it's actually fileless, which means it's not going to drop anything on the file system to change. It's going to operate on that system without going onto that hard disk itself. It could be a process injection attack. It could be some mechanism to operate it from RAM disk. But whatever reason, it may not show up on the disk. The second thing you need to understand about a lot of modern attacks is that they might be frequently what's called living off the land attacks. So the attackers are not going to be dropping a binary. In many cases, they might just use the built-in commands in order to maintain persistence. And this could be something as simple as just shoving a new SSH key onto a user and calling it a day. Or maybe adding a password to a user account that you didn't expect to have login access to. And a lot of traditional file integrity monitoring may not catch that type of thing. Not only that, but there's a lot of attacks that can happen through system timers, cron persistence mechanisms, kernel modules that are getting loaded that you're not aware of. And again, all this can happen without doing any modification of the actual disk in some cases. And in other cases, the modifications of the disk may not be monitored by your traditional file integrity monitoring approaches, such as some of these SSH key attacks I just discussed. What Sandfly is doing instead is we're going to build a profile of that whole box that you can define. And at that point, that profile could be applied to a lot of systems that are identical, and we could tell you whether or not anything has changed on those systems. Not just that, but we can even be used on cloud-based systems, on-prem systems, and embedded devices. So if you have, for instance, IoT devices like a camera or a network device like from Cisco or Juniper, we can actually tell you if those devices have changed at that file level, process level, system user levels, or anything else that we can actually track. So it's a very powerful mechanism. It goes well beyond some of these traditional techniques that you might use. Lastly, something that's really unique with the feature is we operate almost like what we call a diff command. So a diff command on the Linux environment is you could point it at two files and they'll tell you anything that's different between them. We operate like that actually at the host level. So you could profile a known good host as an incident responder and then take that profile and then point it at all the systems that are supposed to be identical to that host. And we're going to tell you anything that's different about them. So if you are scanning 1,000 systems, we're going to say, hey, look, these 7 systems over here have a process on it that we've never seen before, according to your legit profile. So now instead of needing to investigate all these systems, you could just focus on the 7 that matter. So it's a really powerful mechanism. So with that brief overview out of the way, we're going to hop over to the drift detection part of the user interface, and we're going to show you how all this works. So let's get going to that now. All right, so we're in the user interface. Obviously, we don't have any drift profile set up. So the first thing I'm going to do, I'm going to hit new profile. We're going to have a brief explanation about what this is and how drift detection works. You might want to read it to get a better understanding of what's going on. And then I'm going to hit next. Now, the first thing it's going to do is it's going to ask us to select a model host. The model host is a known good image of what you want the profile to be based on, right? So if you're running a bunch of cloud-based images, you would select a host that you know is clean, was set up in an environment where nobody was accessing it and mucking around or anything like that. That's going to be your model host. If you were trying to protect some networking gear, same deal. You would go into your lab and you would say, I'm going to profile this Juniper equipment, or I'm going to profile this Synology system, or I'm going to profile this IoT camera. And that's going to be your model host. And any systems that you monitor should be based on that same platform. So if, for instance, if I did a model host against Ubuntu 22, I would want to make sure that your profile is being applied to other Ubuntu 22 hosts so I don't get a bunch of alerts, because obviously different versions of the product are going to have different outcomes. But you kind of get the idea here. The other thing we could do select host by tag. And what this means is I might have a group of hosts that I'm saying this group of hosts I want to be monitored with the drift profile. So let's say you're running a whole bunch of internet facing servers. Let's say you had a dozen of them and you're like, I don't want any of these things to change. And this is assuming too that you know that they're good and clean. You can go ahead and you could say, just do a drift profile against all 12 of these hosts. And at that point, take that profile and tell me if any of those systems change in the future. So there's different ways to do it. But for today's demonstration, we're going to pick an individual host. Now I know that the host we're going to use today, we're going to use this one here called Drift 0. This is our known good host. And again, this is a system that's running up in the cloud. We could say this is our known good cloud image. We know it's good. No one's been logging onto it. It's been isolated in a way that attackers can't access it. We know this is like the gold image, good to go. The next thing we're going to do is we could decide whether or not we want to apply a tag to that host to say, for instance, hey, this is our model host. And if I do that here, I could put down a tag such as, like drift model. And that's how I know it's my drift model host. The other thing I can do is I could cover my model host with that drift profile. And what that means is after the drift profile is created, I'm then going to apply that profile also to the host I used to make it. So this way it's kind of a self-protection mechanism. It profiles itself, and then when the profile switches to enforce mode, it's now being protected by the profile we use to generate it. This, again, really handy to use, especially if you have deployed equipment already and using us to build a profile off of it. So what I'm going to do now is I'm going to hit next, and then we're going to have some basic default templates. These templates have what we call permissive and restrictive modes in it. A permissive mode means basically we are watching for drift, but we're not quite as strict on certain things. So for instance, we might be looking for a process path, but not necessarily the hash, because processes might be getting updated through normal software update mechanisms. And we have a little bit weaker standards for it. It's still going to find significant drifts to your system, but it's maybe not going to be as noisy, especially for systems that are getting updated very, very frequently. So if you're in that situation, you might want to do a permissive mode. The restrictive mode is, as the word describes, extremely restrictive. We are watching things very, very closely. The slightest change is going to cause a drift detection alert, whether it's a slight change to a binary that's running on the system, a process, a user has slight changes or things like that. So these mechanisms, you could decide what you want to do. We have different servers that you might want to use. So for instance, here, application server would be a generic box that you're just running. A container host here could be a system that's running very dynamic containers. What we're going to do then is we're going to watch the host OS, but we're going to ignore the containers running on it because the containers are changing all the time. We're just going to be concerning ourselves with the host in case there's a container escape. You might also have embedded systems. So if you're doing an embedded system, we expand the things we're watching. For instance, on an embedded system, we might expand and watch all the binaries under the bin, user bin directories, things like that, because again, these embedded devices are not being frequently updated. So if we see a new binary show up, we're going to want to know about it. Same thing here with network devices. Again, we could be very restrictive for Juniper, Cisco gear, or other networking gear that you want us to watch, like Ubiquiti routers are another great one. We can get onto those systems and have a very restrictive profile that if there's anything that's changed on that host, like around the config or new processes running and things like that, we are going to alert you on it. Last one here is whitelist only. Basically, what this does is it's saying, look, I'm not going to do drift. I only want to know about alerts, and I want you to automatically build a whitelist of alerts so I just don't have to bother with doing this stuff manually. Perfectly good option. And finally down here is you're going to pick your own Sandflies. This means you can actually go through, and you should read our documentation. We'll explain it a little bit better, but you could pick what Sandfly modules you want us to run. You might, for instance, only be interested in watching for new process activity with our recon process alerts, or you might only be interested in file integrity monitoring under a certain custom directory. Well, you can make a custom Sandfly to watch just that directory. So that's up to you. For today's demonstration, I'm going to hit application server. These are application servers up in the cloud. We're going to do restrictive because we're not expecting these boxes to be updated a lot. And when they do get updated, we're going to automatically update that profile on our own. So we're good with that whole idea, and we're going to hit next. Now, again, it's just reconfirming a bit of our options that we picked in the default last time. So we already picked restrictive. Here, if you did custom Sandflies, you'd be able to go down this list and pick what you wanted. We did a default template, so it's already pre-selected the ones that we consider good for that particular option, but there might be some things you might want to enable again. So for instance, I might want to say, well, you know what, I want to check for file attributes under the binary directory, so we're going to turn that one on. Or you might want to look for changes in Etsy password or message of the day. If you're doing Juniper equipment, we can watch for Juniper config changes here, so things like that. So just take a look. Now, after I selected that, everything looks good. I'm going to hit next. And then what's going to happen here is if I already scan these systems, I can use the existing results and it'll build a profile with it and we'll be done. If I've not scanned these systems, I recommend using the auto gathering schedule. The auto gathering schedule will run for a period of time. The default is every 48 hours. We're going to run, I'm sorry, not every 48 hours. The default is we're going to run over 48 hours over a certain scan interval of every 60 minutes. And we're going to check those systems. And every time we see something new, we're going to keep adding it to that profile. And at the end of 48 hours, again, it flips over to enforce mode with everything we gathered and then applies it to these hosts. You can shorten this as well. I could say, look, every 24 hours, I want you to scan my model host every 30 minutes. And then so I can have a more frequent scheduling check if you want to do something a little bit faster. That's another option that you can choose to use. Now here, enable whitelisting for covered hosts. Again, I can automatically scan these systems, build a whitelist, and just say, just ignore them. We know we're going to review this when it's done, but for now, we're just going to ignore all these alerts, just add it to the profile automatically. The other thing we could do is run all active Sandflies in every scan. What this does is we will take all those reconnaissance Sandflies and instead of doing our random scheduler or running them, here and there, we will actually run 100% of them every time we touch the host. This is a great option to enable because if you're just profiling a single model host, the extra system impact, in my opinion, is probably not very important to you. You just want maximum information gathering as quickly as possible. This is the best way to do it. Just run them all the time on that particular host over the gathering period. At the end of the gathering period, then it's not going to do that. It's going to revert back to our lower impact settings. So this is fine. But this is going to gather a lot of our whitelist and result data very, very effectively. The next thing we're going to do is we are going to select our covered host. Now it's already selected select individual host, but we don't want to do that. What we're going to do instead, we're going to do select host by tag. And what we're going to say is at the end of this process, apply this to every host with the tag drift on it. So I can add this immediately to all these systems with the drift tag. And every time I put in a new host and I add that drift tag to it, it's going to instantly get the drift profile applied to it. So if you spin up new hosts that are supposed to be identical, again, you just tag them as drift and boom, away you go. Finally, last here we're going to get into a couple more options on this screen. One is apply profile on container results found on the covered host. So here, if you are running containers on that system and those containers are not changing a lot, we could look inside that container for the processes and files and include that as part of the drift profile. But if you're running a containerized host and the containers are changing all the time because it's doing various workloads, you might not want us to look at all the processes because you might not know what's running on it. You only want us to watch the host operating system. So you could flag that here. And at this point, we will not pay attention to the containers running on the system. We'll only pay attention to the host OS. Again, a great feature if you want to protect container workloads against the container escapes, but you don't want to have all the false alarms of the various container workloads. You don't know what's running on the system, right? Now, at this point, we're going to then create a scan schedule to run correctly because, again, it's just a default feature, nice to do. And then we're going to get over to the scan scheduling screen. And what this is going to do is ask a couple basic options. First of all, trickle scanning or immediate scanning. Trickle scanning, what this does is it basically, let's say you had 1,000 hosts you want us to scan. If you do immediate scanning, every time the scheduled security sweep kicks off, we're going to put 1,000 hosts in the queue and we're going to hit them all at once. With trickle scanning, we're going to take that 1,000 hosts and we're going to break it up over the period of time that the schedule is supposed to go. So for instance, if we're scanning once an hour against those systems, we're going to take 1,000 hosts and spread them out over that hour for you. So this is the recommended way we do it because it lowers the network impact. Second of all, priority, leave it at low. Sandfly has no trouble running at low priority, and we have a great reputation of not causing any system stability or performance impacts. And part of that is because we run at low priority and we just don't interfere with the systems. The default here is how often do you want us to check these systems? Every 60 to 120 minutes is our default, but I could change it. I could say, you know, every 60 to 90 minutes, that's fine. If I wanted to, I could restrict to a time window. I could say, hey, look, only run between, you know, midnight and 6 a.m., you know, if it's not business hours or something. For the default though, I'd recommend, unless you absolutely know you don't want us to run on these systems during the day, I recommend letting us run all day. It's very unlikely we're going to cause any system performance impacts, that you're going to see that are going to interrupt. And we really want to be watching systems 24 hours a day if you can let us do that. Now I'm going to hit next here. We're going to give our profile a name, profile drift, and then we'll call it drift demo, and demo, and then we're going to hit finish. Now at this point, you could see here we're in the gather state. Let me click on this profile so we can see what's going on here. First of all, it's going to show us all the hosts that are covered. So all the hosts that are covered with that tag adrift down here, you can see here host adrift. This is what we're going to be covering. These are all the Sandflies you selected to have us as part of that drift profile. These are the reconnaissance Sandflies you're having us run. We don't have any whitelisted Sandflies yet because the drift profile is going to be gathering that data. And as we get alerts, this will start populating out with what's going on. And history just shows you kind of what happened at this point. So at this point here, there's a couple things we can do. We are going to automatically start scanning these systems. And once that starts happening, we're going to start collecting the results. So when that starts happening here, we can then go ahead and review the information, and then it's going to automatically switch to enforce. So what I'm going to do now is I'm going to stop the video. We're going to start gathering some data from these systems. And at that point, we're going to come back and we're going to run through the rest of the drift detection demonstration. So let's go ahead. I'll pause the video. I'll be right back. Okay, the drift detection schedule has been able to run a bit of time now. So we've gone ahead and we've connected to our model host and we started collecting results. I'm going to show you a little bit about how this looks on the drift Sandflies table over here in the drift configuration area. You can see now that we're starting to get results in. So if I sort this out, I can see about 3,000 files we profiled, various attributes, kernel modules, user list, processes that are on the system. We've all started building this into our drift profile so we can then take that drift profile and apply it against the rest of our systems. For whitelisted Sandflies, we don't have any. This is a default build of Ubuntu. It has no alerts out of the box, so we haven't whitelisted anything yet. But if we were whitelisting events, because you had some alerts on your system, you would see them here. And again, you can look at them, see what they are, and then delete them if you don't want them part of the whitelist as part of your configuration setup. But we don't have any out of the box. We don't need to worry about it. So at this point now, we've collected enough data. So instead of letting it run for the full period of time, we're just going to go ahead and switch it over to enforce mode for the demonstration purposes, just to get things kind of moving. So when I go over here and I click on enforce, at that point now, the profile has switched to enforce mode. And if I go over here to my schedules, I can see here that my profile has been created every 60 to 90 minutes. We're going to be checking all these systems. It is active at this point, so it's actually going to get ready to run. And there's two ways now I can make use of the drift. First of all, I could do a manual scan. If I select these hosts and I do a manual scan against it, the drift profile is going to be automatically applied. Or I could just go over here to the scheduler and just hit run, and this is going to force that schedule to run right now. And you can see that when I connect here, that basically the systems are now being pushed into the queue. They're going to be investigated for signs of drift. So I'm going to pause the video and let this finish. And then once it does, we're going to see what results we get back from our newly created drift profile. So let's go ahead and pause. I'll be right back. All right, the drift scan against all of our hosts has completed, and we have found out that we have some problems here. So first of all, I'm going to click over here to the results area, and we're going to see we have our hosts. I have a predefined view called drift, so we'll just focus on that. And at this point, this is showing me all the hosts that are tagged with that drift tag. And this is going to show us basically if anything has been alerted upon. And lo and behold, we have some systems here. I have drifts 1, 2, and 3 down here, but there's one here called drifted, which is showing 14 alerts. So we're going to click on that and we're going to see what it is our drift detection found. Now, again, understand what happened is we took a profile from that drift 0 host. We said this is our known good host. And then we are basically demoing what happened if we have a whole bunch of cloud images that are supposed to be identical and one of them changes. And that's what's happened here. This drifted host is a system where we went on and we did some changes where we loaded up some software to basically cause a very typical attack path pattern, which is something I'm going to show you right now. First of all, under traditional file integrity monitoring, file attributes under the bin directory, we found two new files here called F117 and one called SR71. These green ones are all valid. This means this was part of the drift detection, and that's what we expect. But this one here, and I click on it, here it says that there's a file, SR71 has full cryptographic hashes retrieved, and it's a drift detection alert. It's not part of the profiles assigned to this host. So again, I can see the information about that file. The raw result data contains a lot of in-depth information that can be sent out to your SIEM tool about what the drift actually is. So here again, who owns it, when it was made, is it a link, is it SUID, is it all this other stuff around it? We will show you all that information. The next thing we found down here was file attributes on the Etsy system dir directory. So someone created a couple service modules here that look like they're suspicious. Again, these were not part of our drift profile. So someone created something called the security monitor service, which, as you can guess, has nothing to do with security monitoring. But we pulled that information out to show you, like, hey, someone's dropped this here as a new system D service. We need to investigate. Again, same thing here. File information is available for you. The next thing we pulled over here is a recon process list all, and we found here again, two new processes were shown as running on the host. I can't tell you how important it is to be able to spot an unknown process running on a system. Because if you're watching a bunch of systems that are supposed to be the same, and all of a sudden one of the boxes spins up a new process that's never been seen anywhere else before, you need to go look at that system right now, because there should be no special snowflakes in terms of systems that are supposed to be the same. And that's what's happened here. I'll pick on one of these, this weird process here called SR71. Process name SR71 run on this host. The drift detection is not part of the profile assigned to the host. Sure enough, it's not. Process name is here. Our command line here looks very suspicious. Again, this information is available through the raw results, so you can see all the information available to it. If you have AI analysis tied into this, you can go ahead and run an AI analysis against that result, just as it were any other type of result in our system. Again, you can use an external provider available through the various LLMs out there, through Google, XAI, OpenAI, Anthropic, whatever you want, or you can use an internal LLM provider if you don't want to send any data outside of your network. We give you that option available as well. So when you run this AI analysis, it's going to run just as it would any other type of alert on the system. Now, the next thing we're going to do here is look for something else that's happened. Down here, file attributes on the cron directory. Someone added a new cron tab here for the root user. So again, same deal. It wasn't there before. Someone put this on. Other attributes down here, someone put something in UDEV directory, start scripts, you get it. Someone has added some persistence mechanisms here. Other thing that's added, recon listening port. So someone added something listed on a new network port. This one, SR71, is brand new. These are what we expected to be on there. But this SR71 process, again, if I look at this information down here, I could see very clearly it's got listening information in my JSON information as well. If I want that type of data, I could see exactly that there's something listening here and on this weird port 20,667. Other things down here, finally, systemd service. Yep, someone put a new service called security monitor. We already looked into that. And again, down here, recon user list all. Someone dropped a new user on this box called Johnny. Johnny has given himself all the information, including a home directory. He's given himself a password. He's also given himself an SSH key, as you can see down here. So you should see our video on the SSH Hunter where we could show you how to track this new key being introduced onto a system. It's a really fascinating way to cover this data. But again, these go hand in hand. SSH Hunter and drift detection, it's like peanut butter and jelly, man. Just trust me, go check it out. So at this point now, we've also seen an authorized key file was added. Again, our user Johnny, someone has put an authorized key file on this host. So just looking at all this data here, the drift detection has told us new binaries were added to the host. Someone has kicked off a couple new processes. They've added some systemd services. They've added persistence mechanisms. They added a new user. They gave that new user SSH key. And also on top of it all, they've also put in some cron services, again, as extra security measures to make sure they can keep spinning this thing up and over again. So that is kind of overall a high level view of how the drift detection works on Sandfly. Now, one thing I also need to mention as well with this is that you can use it as an incident responder. And that might be something I covered in another video, but briefly right now, the way I'll cover it is saying this. If you're going into an incident and the customers have no idea about what's going on because they don't have any security deployed, but they say, look, we are running a certain version of Red Hat. You can go ahead, take that Red Hat system, a clean build in a clean environment, do a drift profile on it, then take that profile and run it against the customer systems. At that point, we're going to show you all the systems that are different from that known good clean build. You can then start going through the alerts and seeing whether or not anything there makes sense. If it does, you're like, yep, we know what that is. You add it to the profile, you keep doing that. Eventually, you're going to be left with the things that you don't know what they are. You can then scan the systems again, and again, anything that is of these unusual things that are left over, you're going to see what those are. So if you're scanning a whole bunch of systems for an incident, this is a great way to narrow down what belongs and what doesn't. You can cut through thousands of systems really, really fast with this mechanism. So it's something else that drift detection is very good at doing. So anyway, it's a really powerful feature. I can't cover it all in this video today. I really wish I could. I suggest you give it a play and reach out to us if you want a full demo of it and have any other questions. It's extremely powerful. With our drift detection running on a Linux system, it's extremely difficult for an attacker to get on that box and maintain presence without being spotted. Even with very novel malware, they're going to have a very, very, very tough time doing it. So check it out, especially if you have a bunch of systems that are not changing around a lot and you want to make sure nobody's making changes to them without you knowing about it. Drift detection, agentlessly, really powerful, works on cloud, works on your modern systems, works on legacy, works on embedded systems. Total coverage with Sandfly in a very safe, fast, and compatible way. So I'm Craig Rowland, founder of Sandfly Security. Thanks again for watching the video. Check out our other videos as well for more Sandfly operation tips, tricks, and techniques. Thanks again, and I'll catch you soon. Bye.